All right, in the first video for Notes 101, I went over question 1 and question 2 dealing with radians and degrees and converting between them. Now I want to get into talking about special right triangles and how the special right triangles eventually lead into this lovely mess. This is a unit circle. We will talk about this. Okay, so let's start with special right triangles. So the first one I'm going to draw is specifically, let's snap that, there it goes. I want the 30, 60, 90. All right. So, and specifically, I want the 30-degree angle to be in down right here, and I want my hypotenuse to be 1. Okay, based off of this, 30, 60, 90 rules. Okay, so the rule is this is x, this is 2x, and this is x root 3. Okay, so if this side is 1, then this shortest side is going to be 1/2, and this edge right here is going to be root 3 over 2. So that is your 30, 60, 90 with a hypotenuse of 1. Okay, I'm going to do the same thing with a, or something similar, with a 45, 45. There we go. Love the technology when it does that stuff for me. So 40, whoops, not 40, 45, 45, there we go. And again, I want the hypotenuse to be 1. Now, this one's going to be a little bit trickier because this is x root 2. So if I have 1 equal to x root 2, I'm going to take the root 2 and divide it on both sides. So x is equal to 1 over root 2, which is meh. Not a huge fan of that. I don't like the fact that there's a root in the denominator, so we're going to go ahead and rationalize that out. So this is root 2 over. Now, you can do one of two things in the denominator. You can either write root 2 squared, in which case, well, the square and the square root cancel, and what you're left with then is root 2 over 2. Or the alternative is root 2 times root 2 is the square root of 4. 2 times 2 is 4. And then the square root of 4 is just 2. So whichever way you say it, it doesn't really matter. You're still going to get back to this side being root 2 over 2. And this side is root 2 over 2. That is a horrible 2 down there. There we go. There's root 2 over 2. Okay. And the last one I'm going to draw is just a variation, a reorientation of that first one, where instead of having the 30 in the lower left there, I'm going to put the 60-degree angle there, 30-degree angle there, and yes, I still want that hypotenuse to be 1. So these two edges are just going to invert each other, right? Flip sides here. So this becomes, whoops, this becomes the 1/2, and this becomes the root 3 over 2. That's the same thing, though, okay? Now, the reason I kept making these hypotenuse be 1 is because we're going to start filling in this unit circle. Now, the reason I say start filling it in is because I just want to show you where this first kind of quadrant comes from. And then after that, the idea is these pieces just reflect into the second quadrant. And everything in terms of degrees and radians, I'm going to give you. Okay, so you're not going to have to generate this. So starting with the fact that it is a unit circle. Unit circle means that every radius here is a unit of 1. Every single radius. Okay, so on the x and y axis, these are going to be the easy ones. This is going to be 1, 0. This is going to be 0, 1, right? You're going 1 unit straight up from the origin. This is -1, 0, right? 1 unit to the left. And then down here on the y-axis, this would be 1 unit down, so 0, -1. Okay, so those are the pieces that we're going to start with. Now, secondarily to that, each one of these has a degree measurement and a radian measurement. And so degrees here, we're going to start with 0 degrees, and that is 0 radians. And then we're going to rotate up. This is 30 degrees, which is pi over 6 radians. You can do the conversions. Okay, 45 degrees, that's pi over 4. Again, conversions are always there. 60 degrees, and that's pi over 3. And lastly, we're going to get to 90 degrees, which is pi over 2. Okay. Now, the reason I showed you those special right triangles is because exactly these degree measurements. So what we have here, if we look at this point right here, you could overlay that 30, 60, 90 triangle I drew earlier with the 30-degree angle sitting down here. Okay, and what that gives me is this side is 1/2, this side is root 3 over 2. So then this ordered pair here has an x value, right? This horizontal edge is the x value, root 3 over 2. And then this vertical edge is the y value, 1/2. So what that all put together is this ordered pair would be root 3 over 2, the horizontal x value. And then this is 1/2, the vertical y value. We could do the same thing if we look at the 45, 45, just overlay that triangle, all right? So the hypotenuse is 1, right? There's my 1. And then each of these edges, right, each of the sides was root 2 over 2 here, root 2 over 2 here. So that's your x and y values. So root 2 over 2, root 2 over 2. And then the last one here, last part of the special right triangles for the first quadrant, is that 60 degree, right? So the 60 degrees here, right? 90 here, hypotenuse is 1. So let's see what we got here. We have a 1/2 down here, and then this is root 3 over 2. So let's see, 1/2 root 3 over 2. All right. So that's the way these values are showing up from your unit circles. When you get the unit circle, these are not magical values like somebody just pulled them out of thin air. No, every single one of these comes from your special right triangles, or that each of these spokes, right, each of these radii is exactly 1 unit. All right. Now I'm going to continue rotating into the second quadrant. Okay. So as far as degrees go, this is 120 degrees. This is 135 degrees. This is 150 degrees. This is 180 degrees. Radians. This is 2 pi over 3. Let's see, 3 pi over 4. Again, you could do all the conversions. 5 pi over 6. This is just pi. Okay, because that was the conversion we were using on the earlier part of the note sheet, right? Pi is 180 degrees. And all of these, whoops, I want my highlighter here. All of these points, right, they match, right? They're straight across from each other. The only difference is, well, this is the positive side of the x-axis. This is the negative side. So these x values are just going to become negative when we push them to the quadrant 2 side, the left side here. So this is going to be negative 1/2 root 3 over 2. Let me zoom in on this a little bit better. Negative root 2 over 2 and positive root 2 over 2. And then negative root 3 over 2 and positive 1/2. Okay. Continuing down into quadrant 3 here, back to our degrees. This is going to be 210 degrees. This is 225 degrees. This is 240 degrees. Yes. This is going to be 7 pi over 6. This is going to be 5 pi over 4 and 4 pi over 3. Okay. Again, all the conversions are going to be on your unit circle. And when I say conversions, these pieces of information will be there. Okay. So you don't have to memorize those. But all of these ordered pairs again, right? We took these ordered pairs from quadrant 1, we reflected them into quadrant 2, which made all of these x values negative. Now I can take these values, reflect them into quadrant 3, and now both x and y are going to be negative, right? So all the ordered pairs are negative. Okay, so this is going to be negative. Let me get the first one started here. Root 3 over 2, negative 1/2. This is negative root 2 over 2, negative root 2 over 2. negative 1/2, negative root 3 over 2. Okay, the one down here that we're going to get into next, let's see what we got here. In degrees, this is 270 degrees. That is 3 pi over 2. Continuing into quadrant 4 here, this is 300 degrees. This is 315 degrees. This is, whoops, that is not a 3. That's 330 degrees, finishing off with 360, all the way back to the original part. So let's see if I can figure these out. There's going to be 4 pi over, nope, I lied. That is 5 pi over 3. Okay, so 5 pi over 3. Let's see, 7 pi over 4 and 11 pi over 6. And a full rotation around in degrees is 360. That is 2 pi radians. Okay, now one of two things you can do for quadrant 4. You can take quadrant, whoops, want the highlighter. You can take quadrant 3 and reflect it, making your y values, or keeping the y values negative, but making x positive. Or you can take your quadrant 1 values, reflect those down, keeping x positive, but making y negative. Whichever, doesn't particularly matter. So let's see what we got here. I need x to stay positive, so that's going to be root 3 over 2 negative 1/2 this time. It's going to be root 2 over 2 negative root 2 over 2, and then positive 1/2 negative root 3 over 2. All right, that is your full unit circle. Now, the fun part is you do not have to be able to do what I just did. You don't have to be able to generate it. I just want you to understand where these points are coming from, right? It's all about your 30, 60, 90s, 45, 45, 90s, and understanding this is your degree measurements, these are your radian measurements, and then these ordered pairs, okay? So in the next note sheet, we'll talk about actually using this unit circle to generate information and to solve some pieces of some problems. All right, so that's the end of this video. As always, let me know if you have any questions or concerns, and I'll see you in the next one.